Math Conquerors. Today we are going to discuss the difference of squares and how we can use this to factor polynomials. Now, the difference of squares is defined as a squared minus b squared equals a plus b times a minus b, or a minus b times a plus b. This is our model, and these are some examples. X squared minus 25. We know we can rewrite this as x plus 5 times x minus 5, or x minus 5 times x plus 5. T squared minus 64. We know that we could write it t plus 8 times t minus 8, or t minus 8 times t plus 8. So these are examples of difference of squares. Now let's look at some examples. Example 1, factor difference of squares. Here in our first example, I have 16h squared minus 9a squared. Now I know that 4h times 4h would give me 16h squared, and 3a times 3a would give me 9a squared. So I have two of these. Square means that I say 4h times 4h. So if I have two of them, I can say 4h plus 3a times 4h minus 3a. Example B, 121 minus 4b squared equals 11 squared minus 2b squared, which would give me 211. So I would say 11 minus 2b times 11 plus 2b. Now remember, we're doing difference of squares. So I have to have a minus and a plus so that when I use my full method, the outer and the inner will cancel each other out, leaving me with just the 121 and the minus 4b squared. Okay, let's look at another example. And in this example, it says 27g cubed minus 3g. Now I can take the 3g out of this, leaving me with 9g squared minus 1. I still have my 3g that I took out. 9g squared is 3g squared minus 1 squared, and then I have the difference of a square. 3g minus 1, 3g plus 1, all multiplied by g. You use the full method, factor this back out, multiply this out, and then multiply it by 3g. You would wind up with your original problem. Okay, now let's work some examples. Okay, now we're going to work some examples together, and our first example, 1a, reads 81 minus c squared. Now I asked myself, what is the square root of 81, which would be 9 squared minus c squared, and then I can just say 9 minus c times 9 plus c, because I have 2 9s and 2 c's because they're squared. Example 1b says 64g squared minus h squared, and so I know that 8 times 8 would give me 64, so 8g squared minus h squared. So then I have 8g minus h times hg plus h. If you use the full method to factor this back out, 8g times 8g gives me 64g squared. 8g times h is 8gh, and that one would be positive. The middle would give me a negative 8gh, so those cancel each other out, and then h times h gives me a negative h squared, so I have a negative and a positive. So I come back to my original starting point. Okay, let's look at example 1C. I have 9x cubed minus 4x. Well, I really like to work with squares, so I'm going to factor out an x. So if I factor out an x, that's going to leave me with 9x squared minus 4. And now I have a perfect square here, a difference of a square. So I can say x times 3x squared minus 2 squared, and that will give me x times 3x minus 2 times 3x plus 2. And again, if you use the full method, multiply this back out, then multiply it by your x, you're going to go back to your original starting point. Okay, example 1D says a negative 4y cubed plus 9y. Well, again, I like to work with squares, so let's take out that y. And why don't we go ahead and take the negative out while we're doing it. And that will leave me with 2y squared minus 3 squared. Remember, I pulled the negative out, so it changed my negative to a positive and my positive to a negative. Then that way I have a difference of squares, okay? And so I say a negative y times 2y minus 3 times 2y plus 3. And again, if you use the full method, multiplied it by a negative y, then we go back to your original starting point. Now we're going to move on to example 2. Apply a difference more than once. That means instead of one difference of a square, we may have 2. So let's look at example A. b to the 4th minus 16. Now I know that b squared is b to the 4th, and 4 squared is 16. So I have the difference of a square here. B squared plus 4 times b squared minus 4. But look right here. I have another difference of a square. This is not a difference of a square because difference means subtracting and this is addition. So we're going to leave this one alone, leave it just like it is. But I know that b plus 2 times b minus 2 gives me b squared minus 4. So that's my difference of the square. This is totally factored right here. Totally factored. Do not try to factor this. It is not a difference of a square. Okay, let's look at B. 625 minus x to the 4th. And you're going to have 25 squared minus x squared squared. So that means you have 2 of them. 25 minus x squared, 25 plus x squared. And look right here. Again, we have a difference of a square. This is not, so leave it alone. 5 minus x times 5 plus x. So in some of your problems, you will be able to do the difference of a square twice. We did it one time here, and then we did it another time here. So that was 2 times that we used the difference of a square. Okay, let's try some examples together. We have y to the 4th minus 1. So I have a difference of a square, and I'm going to say y squared squared minus 1 squared. So then I can say y squared minus 1 times y squared plus 1. And then right here, notice I have a difference of a square. So I'm going to say y minus 1 times y plus 1. This is not a difference of a square, so I'm going to leave it alone. And now my problem is totally factored. And if I use the full method, one step at a time, I would go back to my original point. Okay, so let's look at 2b and work it together. So I have 4a to the 4th minus b to the 4th. So I can say 2a squared squared minus b squared squared. Okay, so now I have 2a plus b squared times 2a squared minus b squared. And then look right here. I have a difference of a square. I'm going to leave this alone because it is not a difference of a square. And I know here that I can say, I'm sorry, we do not have a difference of a square. To have a difference of a square, you have to have something you can square. 2, there are no two numbers that when you multiply them together, you get 2. So this is the ultimate answer here. We are not going to move on. The difference of a square has to have a square. Okay, sorry about that.